All right, students, I did want to take some time to teach you one thing that's not in the textbook, and it's not something I'm quizzing and testing, but it is something that I want you to know how to do. Some of you who had geometry last year will remember there was a particular problem and you had no clue how to do it. You hadn't seen this before, where my other students had, and it's taking the root of a root. So maybe in your notes, make a note that this isn't tested, because I don't want you to spend time for the exam studying this, but it's good to know how to take roots of roots. For instance, maybe I wanted to take the cube root of the fifth root of m to the fourth, or something like that. Well, I'd say that the best way to look at this is, remember fractional exponents? We said the cube root could be written as the 1/3 power. So I could write this as the fifth root of m to the fourth, all to the 1/3 power. But this could also be written with fractional exponent. We could say this is m to the 4 divided by 5, or 4/5 to the 1/3 power. And you'll recall that to raise a power to a power, you multiply the exponents. 4/5 times 1/3 equals 4/15. So we could then write this as the 15th root of m to the fourth. And you say, that's a really long process. It is, and taking the root of roots is way quicker. Basically, multiply the indexes. That's really what it comes down to. Multiply the indexes together. Now, if there happens to be a coefficient, you would start by taking the root of the coefficient first. So, for instance, if we had maybe the square root of 16 times the cube root of 7r. Well, I'd start by taking the square root of the 16 to get 4, and then I'd multiply the indexes, the 2 and the 3, to get the sixth root of 7r. That's pretty much it. So not real challenging. Or if I had the cube root of 27 m to the 6th times the fourth root of 8l, something like that. Okay? Well, in this case, I'd start by taking the cube root of the coefficient. Yeah, hopefully you were thinking 3m squared, and then multiply the indexes to get the, and hopefully you were thinking 12th root of 8l. So not particularly hard here, in my opinion. Now, there are some weird instances. For instance, if I wanted to take the square root of the fourth root of 4a squared. Well, again, there's no coefficient, so we'll start by multiplying the indexes to get the 8th root of 4a squared. And then in some cases, we can use that smaller index process, right? By rewriting the radicand as something to a power. Let's come back over here again. And so here, I could then make this the 8th root of 2 squared a squared, take everything out, and end up with the 4th root of 2a. Now, you might be realizing there is a shortcut we could use here, and I love shortcuts. Like, wait a second, if I just took the square root of the radicand and left the 4th root alone, I'd end up with the 4th root of 2a. And that does work as well, as long as you can take the root of the entire radicand. For instance, on the previous problem, the cube root of 8l. Ooh, I could take the cube root of 8. Whoa, hold on. But you couldn't take the cube root of the l, right? Here, for instance, well, that's the 12th root of 2 cubed l to the first. And I can't take something out of all of it. So that's the only reason I would hesitate to try that shortcut, because I can see a person making a mistake there. But yeah, just reduce it down at the end. So if I had the square root of the 5th root of a to the 4th, b to the 4th. Well, again, the conventional method here would be multiply the indexes to get the 10th root of a to the 4th, b to the 4th. And then I can cancel something out of all these numbers to end up with the 5th root of a squared, b squared. Again, could you say, well, I'm just going to take the square root of the a to the 4th, b to the 4th, and leave the 5th root alone? Yes, as long as you could do that with the entire radicand, that would work. All right, so pretty straightforward. I'm going to give you a few problems to practice, and then we'll go over them, and then that'll be it for this short video. Just Again, an algebra concept that you will see very rarely, so rarely in fact that the new edition of the Algebra II book completely removes it, but something the old edition taught that in fact could be beneficial to you. All right, so I'm going to have you take the square root of the nth root of c to the a x squared, the square root of the cube root of x to the n, the cube root of the square root of 7a cubed, the cube root of negative 8 times the square root of a to the 6th, and the cube root of negative 27 times the 5th root of x cubed, z cubed. Take just a few moments, work on these. Go ahead and pause the video until you are finished with these 5 problems. All right, let's see how we did. The first one's kind of obnoxious, but it's obnoxiously easy. Because again, at its core, you're just multiplying the indexes. 2 times n is 2n, so we get the 2nth root of c to the a, x squared. And that's it. Not really that hard, okay? The next one, same thing. We multiply the indexes 2 times 2 to get the 6th root of x to the n. It's that easy. On the next one, avoid the temptation of taking the cube root of the radicand because you can't. You can only take the cube root of the a cubed. So multiply the indexes to again get the 6th root, this time of 7a cubed. And if I could write that as a cube or as something like that, I could reduce it, but I can't, so I'm done again. Here on this next one, start with the root of the coefficient. The cube root of negative 8 is negative 2. And then multiply the indexes to get the 6th root of a to the 6th. Then you should be thinking, wait, that's just a. So negative 2a. And there's our answer. Either there was a shortcut. I suppose if you happened to notice that the square root of a to the 6th is a cubed, then this could become the cube root of negative 8a cubed, which is, of course, negative 2a. So a couple ways you could have gone with that one. And then on the very last one, again, take the root of the coefficient first to get negative 3, multiply the indexes to get the 15th root of x cubed, z cubed, and then I would take a 3 out of the 15, the 3, and the 3 to get negative 3 times the 5th root of xz. The alternative, of course, is you take the cube root of the negative 27 to get negative 3. You go ahead and take the cube root of the x cubed, z cubed, leave the 5th root alone, and of course it's the same answer either way. And I think I may have just gone off the screen. Nope, I didn't hit fit. All right, hopefully this makes sense to you. You will probably see a bonus in the days ahead. Actually, you know what? I think I'm going to give you just a couple more. I'm going to give you just a couple more. But yes, you will see a bonus in the days ahead. And so I wanted to give you an opportunity to do well. I'm going to ask you this. Before we do this last round of problems, so that I know you've watched the video, if you'll go ahead and click like. Okay, I'm not chasing likes. I don't usually ask for likes. But since I'm assigning this as homework, I want to make sure you're doing the homework. So go and click the like button. And then once you've done that, we'll go ahead and work these next few problems. Once again, pause the video, work these 3, and then I'll go over the answers in just a moment. All right, start by multiplying the indexes to get the 6th root of a to the 6th, x to the 4th. You should see that 6 goes into 6 one time with nothing left. 6 does not go into 4, but I can take out 2 out of both of these and end with a times the cube root of x squared. There's another way you could approach it, but for sake of time, I'll just show this. I don't want you to take too long watching this homework video. Here again, multiply the indexes to get the 6th root of 2 squared x to the 4th y to the 4th. Cheat a little bit and skip and do 2 steps at once, and that'll give you the cube root of 2 x squared y squared for my answer. On the next one, we'll multiply the indexes to get the 12th root of 729. And I wonder if that's something squared. So we try taking the square root of it. No, it doesn't. Or does it? Does it work out? 27 squared, maybe? Yeah, I think that's it. So we try taking the square root of it. Yeah, that's 27 squared. And if we do that, that could give us the sixth root of 27. Wait, that's 3 cubed. So this will give us the sixth root of 3 cubed. This becomes the square root of 3. And there's our answer. A couple other ways you could have approached it. You could have recognized this as a 9 cubed. Okay, and gotten the 12th root of 9 cubed. In fact, that's actually the way we should have thought of it. We memorized that. Yeah, sorry, brain glitch on my part. I was thinking there's some numbers I didn't have you memorize. I used to have students memorize. This wasn't one of them. You memorized 9 cubed. So you should have gotten 4th root of 9, and that's the 4th root of 3 squared. That's how you should have gotten square root of 3. Yeah, 27 squared. We didn't go that high. But 9 cubed we did. All right, now this next one, again, multiply the indexes to get the 2nth root of a to the 4th x to the 8th, and there is a 2 in everything. And so that ends up giving me the nth root of a squared x to the 4th, and that's all we can do because I don't know what the n is. If it's another even number, I could do more, but I don't know if it is or not, so we'll leave it just like that. All right, trust you understood this fairly well, and again are ready in case I throw a bonus on a quiz coming up here in the near future. All right, this will wrap up our section on roots, and we'll be transitioning into a much more enjoyable section, I think. We need a reprieve after the challenges of rational expressions and then radical expressions. So we're getting into equations, which I think for most of you will be a big sigh of relief as we head into exam week. All right, have a great rest of your day.